Have you ever used propane fuel to cook or gasoline to drive a car? These are both hydrocarbon fuels, but they both have different amounts of hydrogens and carbons. Chapter 3 is all about organic chemistry. First, we're going to look at organic compounds. So, the word organic means relating to or derived from living organisms. So, in organic chemistry, this is defined as the study of molecular compounds of carbon. So, compounds containing carbon based ions, um, like carbonate, are not considered to be organic compounds because they contain ionic bonds. So, we're going to be looking at molecular compounds of carbon. So, of the over 10 million chemical compounds that have been discovered, at least 90% are carbon based molecular compounds. The properties of organic compounds are a result of the covalent bonds within their molecules. So these are bonds between two nonmetals, so they share electrons. Um, and this happens in their valence level. Carbon has the highest number of bonding electrons in any element, which is 4, because it only contains 4 electrons in its valence shell. So this has a high bonding capacity, and they have the ability to form shapes, rings, spheres, tubes, and sheets of almost any size. Carbon can also form single, double, or triple covalent bonds. So Lewis dot diagrams are helpful for both small molecules and large molecules, but they're awkward and more complex, so we typically simplify them using a dash between the two different substances. So, and we write them in their chemical, more of a complex, simple chemical structure. So we'll go CH3 instead of drawing C with 3 H's around it. So to the right are 6 different ways of illustrating the compound C5H12. So we can do our Lewis dot diagram, our structural diagram, or our condensed structural diagram. So you can see that the condensed structural diagram is the simplest of all of those. We can also draw the expanded molecular diagram, a simplified structural diagram, which is number 5, or the line structural diagram was number 6. My personal preference when I'm drawing molecular compounds is number 5, the simplified structural diagram. We just assume there is H's at the end of each of those dashes, and if we're ever adding a molecular compound that's not an H, like a chlorine or an oxygen, we would then write that one in. So it's easy to identify which additions to our carbon structure are not hydrogen. So in order to manage the enormous number of different compounds, chemists divided them into different families based on what makes them special. So we divide them by the types of bonds. So they can have single bonds, double bonds, or triple bonds. And this is what we're going to look at over the next few lessons. So there are also functional groups that we can add with elements other than carbon and hydrogen. So sometimes we can add hydroxides, which will make an alcohol. So this is a compound that has different chemical properties, such as higher solubility and flammability. And one of the things ethanol can also be added to is our fuel. So first, we're going to look at alkanes, which are hydrocarbons, so hydrogens and carbons containing only carbon and hydrogen atoms. And in an alkane, these are hydrocarbons with only single carbon-to-carbon bonds. The general formula for alkanes is CnH2n plus 2, because the N stands for however many carbons there are. With hydrogen, each carbon can bond to 2 hydrogens if it's bonding to the other carbons. And then there's 1 extra hydrogen at the beginning and at the end of the chain. So you have the general formula for alkanes in your data booklet. As the size and molar mass of an alkane increases, its boiling point increases. So the bigger molecules have more bonds, and then more energy is needed to break them apart to change their state. So the smaller a hydrocarbon is, the lower its boiling point. So all alkanes, methane, ethane, end in ane. That's the suffix of their single bonded hydrocarbon. The prefix, meth, eth, or prop, indicates how many carbons are in the chain. And in your data booklet, you have a list of what the prefixes are depending on how many carbons there are. So notice that the first 4 are gases because they have the lowest boiling point, and the next 12 are, and the next up to 10 are liquids because their boiling point is lower. It isn't until we have very large hydrocarbons like C17H36 that they're large enough to be solid. So when you're naming alkanes, we're going to go through a series of steps. The first step is to identify the longest continuous chain of carbon atoms, and this will be the parent chain in our structural diagram. Now, the parent chain can be straight or it can have a curve in it, so it's important to count carefully. So they might not be in a straight line, but they must all be connected. So with either of these, we could make a straight carbon chain or we could have a bent carbon chain as long as there's the longest chain of carbons in it. So in the one on our left, we have a 4 long carbon chain, and on our right, our maximum length carbon chain is 3. We want to number the carbon atoms in the parent chain, starting from the end closest to a branch. So in this one, because we have a carbon that's not part of our parent chain coming off of our alkane branch, we want to start numbering on the left because that then branch can be off carbon 2 instead of off carbon 3 if we started numbering from the right. So our carbons are going to be 1, 2, 3, 4 from left to right. In our second carbon atom, it doesn't actually matter which direction we number them in because no matter what, our carbon is going to be branched off carbon 2. So then we want to name it. Determine how many carbons are in the parent chain to determine its prefix. Because there's only single bonds, it means no matter what, the end is going to end in ane. So 4 carbons is going to be butane, and 3 carbons is going to be propane. And this is, again, all on page 9 of your data book for a complete list of alkanes. Step 3 is going to be identify any branches and their location using the number on the parent chain. So branches always end in YL, and the prefixes are the same as our alkane naming. So meth would indicate 1 carbon, eth would be 2 carbons, prop would be 3 carbons. And this is going to indicate how many carbons are in the branch. So on the butane, we have 1 single carbon branch on the second carbon of the parent chain. So we're going to go 2-methyl. Meth identifying that there's 1 carbon on the branch, 2 identifying the location, and YL indicating that it's not part of the parent chain. If the compound has more than one of the same type of branch, we list both numbers even if it repeats. So on our second carbon, our propane, we have 2 single carbon branches on the second carbon. So we're going to go 2,2-dimethyl. So we have on carbon 2, we have 2 single carbon branches, so we're going to go dimethyl. So there's 2 methyl branches. So then we have to write the complete IUPAC name following the format. The number of the location of the branch, followed by the branch name, and then the parent chain. So 2-methyl butane. Off carbon 2, we have a single carbon branch on a butane molecule, 2-methyl butane. For our second example, we have 2 branches, both located off carbon 2. So it's 2,2-dimethyl, 2-methyl, 2 single carbon branches on a propane. When there's more than one type of branch with carbon, one might be a single carbon and one might be a double carbon, we want to write them in alphabetical order. So our ethyl branch would come before our methyl branches. So we identify our 10 parent chain, which would be decane. We have 4 methyl branches, 3, 4, 4, and 6. And so 3, 4, 4, 6 tetramethyl. And 1 2-carbon branch on carbon 5. So this would be 5-ethyl. Then we put it all together again in alphabetical order. So we have 5-ethyl, 3, 4, 4, 6 tetramethyl, decane. Now, when you are going to be naming compounds from textbook questions and on exams, typically they won't have 10 carbons. So you'll be looking at much smaller hydrocarbon compounds. So we're going to name this compound. So the first thing we need to do is identify how long our main carbon branch is. So if I count, I can go 1, 2, 3, 4, 5, 6, but I also want to count and double check that this doesn't make it any longer. So 1, 2, 3, 4, 5, 6. It doesn't, so for ease, I'll make this my long carbon branch. Then I can see my parent chain. Then I can see I have a branch here and a branch here, one with 1 carbon and one with 2 carbons. And again, I had that 6 carbon chain there. So I want to number them from branch numbers. So the branch numbers will be lowest to highest. So I'm going to go with 1, 2, 3, 4, 5, 6. And we're going to use this information to answer to name this compound. So here we go. The parent chain is identified, and we've numbered the branches we've numbered the carbon so that the branches have the lowest possible prefix. So we have a 6 carbon, so it's hexane. Step 3, we want to identify the branches. We have a methyl branch because it has a single carbon on C2. So we'll have 2-methylhexane. And then lastly, we have to identify our ethyl branch, which comes first alphabetically off the 3rd carbon. So it's 3-ethyl. Finally, putting it all together. 3-ethyl, 2-methylhexane. So we're, again, remembering when there's more than one branched group, we have to name them alphabetically. To draw alkanes, we start with the IUPAC name from the back of the compound. So we'd end up drawing our parent branch first. So the end of this one is going to be pentane. So this is a 5-carbon parent chain. So we draw the skeleton of the parent chain, and we can number our carbons 1 through 5. Then we have 2,4-dimethyl. So this is a single carbon branch off carbons 2 and 4, so we can draw those in. Lastly, we have a 3-ethyl, which will be a 2-carbon branch off the 3rd carbon. We're going to put this in from the top so that there's room to draw it in. The last step is to fill any unfilled bond sites with hydrogen. So don't add too many because remember each carbon has a maximum of 4. Now this diagram was perfectly correct before you added in the hydrogens, but remember to always answer the question as it was asked for a complete structural diagram or a simplified structural diagram. So like I said, that depends on what your question is asked. So remember, when we're naming our alkanes, we want to count the amount of carbons in the parent branch, parent chain, identify any branches, and then name them in alphabetical order.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.